In this video, we will be taking a look at the heating of the Earth. Part of the reason that we study astronomy in Earth environmental science is to understand Earth's place in the solar system, where it is in relation to the sun, and why it's the perfect planet to support life. And part of that is how heat is transferred from the sun to the Earth. So heat is transferred from one object to another because difference in object's temperature. Heat always travels from hot to cold. Temperature is a measure of the average kinetic energy of atoms or molecules in a substance. So temperature and heat are a little bit different. So if you see in the diagram in our animation down here, something that is warm has more energy. So the molecules move rapidly, which causes the mercury to rise in the thermometer. So heat affects the temperature, but temperature has to do with the movement of molecules. All right, so the way that we get energy from the sun is through electromagnetic waves. The sun emits light, it emits heat, and also ultraviolet waves. Those are the waves that hit our skin, cause us to get sunburn or suntan. And these forms of energy are a part of what is called the electromagnetic spectrum, all types of radiation that are emitted from the sun, from the shorter wavelength gamma rays all the way to the larger wavelength radio waves. And of course, of that, visible light is just a narrow portion, and that's the only part of the electromagnetic spectrum that our human eye can pick up. It's the only wavelength our eyes can detect. All right, and there's three ways that energy can transfer. You may have heard these terms before. They are conduction, convection, and radiation. Conduction is the transfer of heat through matter by molecular activity. What that means is molecules have to touch or collide in order for heat to be transferred. So in our example over here, when the hand touches the hot pot, the heat is transferred from the pot to the hand. Convection is transfer of heat by mass movement or circulation. Usually what happens in a fluid, whether it's liquid or air, heat rises and cold sinks. So in our pot example, once again, the bottom of the pot is closest to the heat source, so it's going to be hot. As the water is heated, it rises, and the cooler water at the surface sinks to the bottom, where it is then heated and causes that circulation. That's why when water boils, you see the bubbles rising to the top. The third type, radiation, is a transfer of energy through space. So it's electromagnetic waves that travel out in all directions. So looking back at our pot, it's heat that is transferred without touch. So you can put your hand near the pot and you can feel the heat radiating outward. You can put your hand near a fire. You don't have to touch it to feel its heat. And that's how the solar energy reaches the Earth. It does not need a material to travel through, like conduction needs touch, convection needs a fluid, but radiant energy can travel through empty space. All right, so radiation, going into a little bit more detail, all objects are going to emit radiant energy at any temperature, whether it's hot or cold. The hotter objects are going to radiate more total energy per unit area than the colder objects do, which is why when you get near them, you feel that heat. The hottest radiating bodies are going to produce the shortest wavelength of radiation. And also, objects that are good absorbers of radiation are good emitters as well. All right, so when radiation strikes an object, there are three different things can happen. Some of the energy is going to be absorbed, which is why the items are hot to the touch. Some substances that are transparent are going to allow some of that energy to penetrate and move through, and then some radiation may bounce off or be reflected without being absorbed, without being transmitted through. So if we look at what happens to solar radiation as it comes towards the Earth, only about 50% is absorbed by the Earth's surface, whether it's land or water. You can see 5% is reflected by the atmosphere, 20% from the clouds, and 20% is absorbed. So we have a lot going on. So not all of the solar energy is going to reach Earth's surface. Okay, so some of the solar radiation that is not absorbed is reflected or scattered. Reflection occurs when the light simply bounces off an object. And the reflection radiation So the light or energy that's reflected has the same intensity as the incident radiation. So if you're looking at a mirror and sunlight's bouncing off, it's going to affect your eyes just the same way as it would to look directly at the sun. Scattering, on the other hand, produces a large number of weaker rays because you're scattering the light and it travels in different directions. All right, as far as absorption goes, we mentioned that about 50% of the solar energy that strikes our atmosphere actually reaches Earth's surface and is absorbed. Of the heat that is absorbed, some of it is re-radiated back into the atmosphere, and that warmth that is being re-radiated can be trapped by water vapor and carbon dioxide, which are two of our main greenhouse gases. And that's what keeps our Earth warm enough for us to survive. If that heat were simply reflected back into space or emitted back into space, our Earth's surface would be much too cold for life to exist the way it is now. All right, so when we look at temperatures of various cities or locations, there are factors other than latitude that can influence temperature. We know that latitude affects because the closer you are to the equator, the more direct the sunlight. And as you move to higher latitudes, whether it's north or south of the equator, temperatures are going to cool down. But there are other things that can affect temperature too. The heating of land and water, the altitude of your location, your geographic position, what the cloud cover is, and the ocean currents in your area. So when we look at the heating of land and water, land is going to heat up more rapidly and to higher temperatures than water does. It also cools much more quickly. If you've ever been to the beach and during the daytime the sand is much hotter than the water, or even at a pool, if you're on the pool deck, it's a much higher temperature than the water. Part of it is because water has a high specific heat, meaning it takes a very long time for it to absorb heat to heat up. Also takes a long time for it to cool down. So at nighttime, generally your land is going to be cooler than the water because the water has retained what heat it has absorbed. Okay, if we look at windward versus leeward climates, windward is when you have breezes coming off of the coast or prevailing winds coming off of the coast that blow that moist air onto the land. So you're going to have cooler summers, milder winters, generally a lot of rainfall, whereas the leeward side of the mountain is going to be much drier. We also have leeward coasts where your winds are blowing from the dry land towards the ocean. They're going to have a more normal continental temperature with greater differences in temperature range between seasons. Here's another example. Vancouver is a city in Canada that's on the coast, whereas Winnipeg is in the middle of the continent. And you can see Vancouver doesn't have quite the range of temperatures. It's got a much milder winter, whereas Winnipeg, which is surrounded by land or continental, goes to much more extremes, colder in the winter and even warmer in the summer. Altitude can affect temperature. Altitude is the height above sea level. So generally what happens, the higher you are in altitude, the cooler your temperatures are. If we look at these two cities, we have a coastal city here in represented by the blue, and it's at a represented by red, it's at a lower altitude. And we have our city here represented by blue, that's a higher altitude. And you can see the higher altitude experiences much cooler temperatures. All right, two more examples. When we look at geographic setting, this also affects the temperatures. Areas that are continental versus coastal, but also depending on the ocean surrounding those areas. If we look at Eureka, California, which is on a windward coast, meaning you've got the wind blowing in from the ocean. Then we have New York City, which is leeward because we have our wind blowing from the land out to the water. So New York City is going to have more of a continental climate where you've got the bigger range, and Eureka is going to be more mild because it's the windward coast. If we look at Seattle and Spokane, Seattle is on the windward side of the mountain, Spokane is on the leeward side of the mountain where it's much more dry. Okay, then our next to last temperature control is cloud cover and albedo. Albedo is a measure of the amount of radiation that is reflected. So the higher the albedo, the more reflection. So ice, like our polar ice caps, have a higher albedo than just bare soil. So when our ice caps melt, the Earth is actually absorbing more heat, which also leads to raising temperatures. So clouds tend to have a high albedo, meaning that they are going to reflect light. And so when it's overcast during the day, the temperatures tend to be a little bit cooler because a lot of that light is not making it to Earth's surface. However, the opposite happens at night. At night, the clouds are going to trap that heat that was absorbed by the Earth during the day. So if it's cloudy at nighttime, it tends to be warmer than normal. And our last temperature control are ocean currents. We know that the equator gets more direct sunlight, and if you notice, our currents by the equator are much warmer. So the water at the equator moves towards the poles, and the cooler water from the poles moves back towards the equator. And depending on where you live, you can be affected by the temperature of these ocean currents. Here's a satellite picture of the ocean. You can see the land is in gray, and by the equator we've got our warmer temperatures, and as you move to the higher latitudes towards your poles, the temperatures cool down. So that's it for heat transfer and how solar energy affects our Earth.